RTL restructuring is a method to modify the RTL code during the development stage before synthesis. It is mainly modified for PPA optimization purposes, but it also helps improve readability, reusability, and synthesis efficiency. RTL restructuring can be done either manually or by EDA tools. This kind of restructuring will be designer-friendly and easy to analyze if the changes are properly made and managed. If restructuring is done manually, the functionality should not be affected because it can cause verification issues. Manual RTL restructuring is not feasible nowadays due to the increased complexity of RTL architecture. It would lead to numerous problems. Therefore, it is better to use an EDA tool for restructuring. Manual RTL restructuring requires more design skills, while restructuring using EDA tools will perform better than manual if the rules are followed. Restructuring with EDA minimizes time and errors compared to the manual process. It is also an automated approach with minimal time to complete. Some methods of RTL restructuring include grouping, ungrouping, moving, removing, and adding instances or modules, inserting parameters for control, and preserving formatting and comments. The main point is that the restructuring should not alter the design's functionality. Sometimes, these RTL restructuring methods may change, increase, or decrease the hierarchy levels. It also involves restructuring across different abstraction levels or modules. The challenges in the RTL restructuring include the risk of naming collisions during modifications, which can sometimes break connections between the two nets. It will be a time-consuming process that often leads to errors after modifications. Multiple verification steps will be necessary. Additionally, it can create multi-driven nets, causing conflicting assignments between modules. The solutions to the challenges include properly using the tool to understand the hierarchy, automating the restructuring process with scripts in the tool, applying formal equivalence techniques to periodically check for logic errors, and also employing linting tools for data and setup checks using the tools. Here are the Verilog code examples for the sample counter design before and after RTL restructuring. The first code is the implementation before restructuring, which shows a 4-bit counter. The second code is after RTL restructuring, illustrating that the 4-bit counter module is separate and its output is fed into a top module called core to display the final output. The RTL is restructured so that the main functional module remains separate with a top module used to present the output. This approach helps to better understand the main functional module. RTL restructuring mainly improves design clarity for better readability and also enhances PPA. The methods include adding, removing, grouping, and ungrouping instances. Creating better RTL code through restructuring that yields good PPA makes the synthesis more efficient.